Hello everyone. Okay, so in this video we are learning about arithmetic sequences or linear sequences. So if you recall, a sequence or a pattern, well, it's just like a pattern of numbers. You know, if I have a group of number like this, 2, 5, 8, 11, I can see there's a pattern going on. It's increasing by 3. So there are a few different patterns that we learned in this chapter. So this video we're going over arithmetic sequences, right? Or arithmetic patterns. So a linear sequence or an arithmetic sequence is known as a sequence that increases or decreases by the same amount. So if we see for this sequence here, my first difference, this is known as my first difference here, this red thing, is 3. So therefore every term is going up by 3. So I know then the fifth term would be 14, the sixth term would be 17, and so on, right? So a linear sequence can go, a linear sequence goes up or it goes down the same amount. So to find the general form of a linear sequence, so it's all well and dandy me writing out the first 7 sequences like this or 6 sequences like this, but what if I want to say find the 257th sequence, find the 473rd sequence, right? Term in the sequence. So that's where we use our general form. It's kind of like a function, if you will, where we put in n, which is our term number, and then it spits out tn, which is our term value, right? So subscript n just means the term value. So for this sequence here, when n is equal to 2, t2 or the second term is 5, right? So when t is equal to 2, t2 is equal to 5. So let's have a look at this formula here. So to use this formula, this is in your log tables. So it is a plus n minus 1d, where a is the first term, d is the first difference, right? So once we have the first term and the first difference of a linear sequence, we can solve for the general term. So finding a general term, so the general term of a sequence lets us quickly find the value of any term in the sequence without having to calculate all preceding terms. So to find the nth term, we verify a sequence is linear by finding the first difference. Recall the general formula. We find what a and d are, so my first difference and my first term, and then we sub it into my formula, and then we have an equation of n. So let's have a look at this question here. Right, so let's have a look at this question here. A sequence is defined as 5, 10, 15, 25, 35. Show that the sequence is arithmetic or linear. So I can show that it's linear because it goes up in tens. It goes up in tens. So plus 10, plus 10, plus 10. The first difference is the same. Second part, find tn, the nth term. So again, so tn equals a plus n minus 1d, where a is my first term and d is my first difference. Well, what's my first term in the sequence? Well, my first term is 5. And then my difference is equal to 10. So tn is equal to 5 plus n minus 1 times d, which is 10. Tn is going to be equal to 5 plus 10n minus 10. Tn is going to be equal to 10n minus 5. And that is my general term. Right? Hence, find the 20th term. If I want to find the 20th term, well, I'm subbing in n is 20. So I have t20 is equal to 10 times 20 minus 5. T20 is equal to 195. So I know the 20th term in the sequence is 195. And finally, the last part here, I want to find the first term that is greater than 450. So I want to find out, now I'm solving for n. I want to find out when Tn is greater than 450. So we have an inequality here. So I know Tn is equal to T10n minus 5 is greater than 450. 10n is greater than 450. Bring this over, it'll be a plus 5. 455. N is greater than 45.5. So when n is greater than 45.5, now this brings up a good point. I can't really have 45.5 terms, right? So my answer here is going to be n is equal to 46. So when during my 46th term, that is when my sequence will be greater than 450. So there's an example there. Let's look at some exam questions now. So this is one from 2021, paper 1. The first three terms in arithmetic sequence are minus 5, k, and 1. Find k and hence or otherwise show that the common difference is 3. So I know it told me here it's an arithmetic sequence or a linear sequence. Therefore, the first difference is the same. Therefore, this difference, we'll call it x, is going to be the same. So I know minus 5 plus 2x, because if I hop it twice, 1, 2. 5 plus 2x, that should equal to 1. 2x is equal to 1 plus 5. 2x is equal to 6. X is equal to 3. So my first difference is equal to 3. And then I want to find k. So k is just going to be equal to minus 5 plus 3, which is minus 2. So k is equal to minus 2, and my first difference is 3. Find Tn, the 10th term in the sequence. So again, if you kind of forgot your formula, you can just keep adding 3 on your calculator until you get to the 10th term. But I'm going to use my formula for this question. So Tn is equal to a plus n minus 1 d. Tn, my first term is minus 5, n minus 1, and my first difference is 3. So Tn is equal to minus 5 plus 3n minus 1. Tn is equal to 3n minus 8. So I'm looking for Tn. T10. So I'm looking for the value of my 10th term. So that's going to be 3 times 10 minus 8. T10 is equal to 30 minus 8. T10 is equal to 22. Therefore, the 10th term is equal to 22. Then finally, find which term in the sequence has a value of 247. So I want to find out when Tn equals 247. So my term value equals 247. So I can't really solve this. So I need to put in my formula. So 3n minus 8 equals 247. 3n is going to be equal to 247. Bring over the minus 8. That becomes a plus 8. 247 plus 8 is 255. And n is going to be equal to 85. So the 85th term has a value of 247. Let's look at some more questions now. So this is from the 2020 paper. So the following sequences of patterns is created by matchsticks to form equilateral triangles. Complete the table below to show the number of matchsticks required to make each of the first 6 patterns of the above sequence. So these are all matchsticks. Yeah. So basically each matchstick corresponds with a side of the equilateral triangle. So This one has 3. This one has 1, 2, 3, 4, 5, 6, 7. This one's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? And we've noticed here it's going up in 4s. So therefore, the next one's going to be 15, then 19, then 23. So it's going up in 4s. How many matchsticks are required to make the pattern 10 of the sequence? So pattern 6, 7, 8, 9, 10. So 23, 27, 31, 35, 39. So it's going to be 39 matches to make 10th pattern. Find the formula Tn for the number of patterns. So for Tn for the number of matchsticks required to make a pattern of n in the sequence. So Tn is equal to A plus n minus 1 d. Tn is equal to, my first term is 3 plus n minus 1 d. My first difference is 4. So A is equal to 3, d is equal to 4. Tn is equal to 3 plus 4n minus 4. Tn equals 4n minus 1. Right. Pattern K has 147 matchsticks, where K is an element of natural numbers, right? So find the value of K. So I know TK is equal to 147. So I have 4n minus 1 is equal to 147. 4n is going to equal to 148. N is going to be equal to 37. N is equal to 37. So the 37th pattern uses 147 matchsticks. Right. There's 2 more questions left here. This one is from the 2019 paper. So notice this comes up very, very frequently. It always appears. So a company was set up in January 2016 to repair engines. In the first month of its existence, the company made a loss of 4,000. This loss reduced by 250 a month for each month that the company traded. Complete the table below to show the company's loss/profit for the first 6 months of trading. So every month, this loss is decreasing by 250, or we're adding 250 here. So our profit's increasing by 250. So it's going to be minus 3,500, minus 3,000, and then minus 2,750. Show that the profit of the company makes a month is given by this formula. So remember, Tn equals A plus n minus 1d. A is my first term. So my first term is minus 4,000. D is my difference, which is 250. So Tn equals minus 4,000 plus n minus 1 times 250. Tn equals minus 4,000 plus 250n minus 250. Tn equals 250n minus 4250. And there you go, I have proven it. Now, remember, if you're in an exam and for some reason you couldn't get this out, right, just make a note of that, because they did give me the formula. So if you already gave me the formula, I won't be getting marks now if I use my incorrect answer in subsequent parts. So let's look at this part here. What month did they break even? So i.e. they make a €0 profit. So I want to find when Tn equals 0. So they're not making a loss, they just broke even. Tn equals 0. So 250n minus 4250 is equal to 0. 250n is equal to 4250. N is equal to 4250 divided by 250, which is 17. So during the 17th month. So what month did they break even? 17th month. And then finally, this last question here, 2019 paper 1 question 14. So This is from the Junior Cert higher level paper. So the first three terms of sequences are as follows. Fill in the following table to write each of the first differences in its simplest form in terms of x. So I have here, I know term 2 subtract term 1. Right, so it gave it to me here. That's going to be equal to, well, that's going to be, so x squared minus 2x minus 6x plus 3. X squared minus 8x plus 3 equals 0. Oh, yeah. Well, don't need to do equals 0, just do that. There you go. So that is kind of my first difference. So here, I know I want to find term 3 minus term 2. So 4x squared plus 3x minus x squared minus 2x. So 4x squared plus 3x minus x squared plus 2x, because remember minus by minus is a plus. 3x squared plus 5x. There it is there. So I found now two expressions for my first term. So what we're going to do now is, it's asking me here, show that if the terms form a linear sequence, then 2x squared plus 13x minus 3 equals 0. So what do they mean by that? Well, these are both my first differences. So I know x squared minus 8x plus 3 equals 3x squared plus 5x. Right? So bring everything over to one side. So 3x squared minus x squared plus 5x plus 8x minus 3 equals 0. 2x squared plus 13x minus 3 equals 0. And I have proven the answer there. Right? So there are some questions there on linear sequences. So, or just a kind of a general introduction to linear sequences. And I hope this video was some help to you guys. And I'll catch you guys later. Bye.